Okay, cool. Hello, everyone. Thank you very much for attending this week's Corundum developer meeting. So not much going on in terms of the status updates for today, just a couple things to talk about, and then we'll open it up for discussion. All right, so status update summary. I've been doing some kind of reorganizing in the code base, and I've merged all of the 10 gig and 25 gig designs. So I'll talk about that a little bit. I've also done some work on the driver, reworking kind of the IOCTL API calls so that now you can actually map all of the bars now from user space using the existing framework. So that should make things a little bit easier if you're doing some work with the application section. Most everything else at this point is to do. All right, so we'll go ahead and go over these main couple of changes here so far. So first one is the unified 10 gig, 25 gig designs. So previously, for most boards, I had a design that ran kind of at the board's capability. So if the board had run at 100 gig, I had a 100 gig design. If it ran at 25, I had a 25 gig design. If it ran at 10, I had a 10 gig design. And for stuff that ran at 100 gig, I usually had a design at either 10 gig or 10 gig and 25 gig. But the 10 gig and 25 gigs were almost identical. The only differences are, effectively the data path width and the transceiver settings. And then I think a couple of like pipelining settings were slightly different. But with dynamic switching, we can make the 25 gig design the default basically. And there isn't really as much need to have the 10 gig design for each board. But there are potentially some reasons that you'd want a design that's natively 10 gig, right? You have a slightly narrower data path, so slightly lower resource consumption. And also it's definitely easier to close timing at 156 megahertz versus 390. And the power consumption is going to be a little bit less. But the differences here are pretty minor. So that means a 10G design can be basically a configuration variant of the 25 gig design. We don't need a whole other set of RTL. We can just add some stuff to the config.tcl file. And when you build the project, it will change all the right settings so that things work. And this simplifies maintenance and testing because, I have now effectively just two design variants for each board. I have the 100 gig design, I have the 25 gig design, and then the 25 gig design also, when you slow it down, it runs at 10 gig. So makes things a little bit easier to maintain. So what I've done is I've gone ahead and taken every board that's capable of running at 25 gig and I've converted the 10 gig design to 25 gig design or to 25 gig, or I've, merged the two if there were two. And then the 10 gig design is now just, a make file and config.tcl inside of the 25 gig design. So makes things a little bit easier to work with. All right, so that's all done. The other thing that I just finished up over the past few days is getting the driver IOCTLs reworked. And the idea here is to permit the IOCTLs to expose a much larger and more comprehensive collection of regions versus what we had previously. So previously, the only thing you could do is map the NIC control register space, which, that's important. But with the application section, and eventually we're going to have the RAM bar operational as well, you're going to be able to want to do more than that. So what I wanted to do is instead of, some ad hoc solution that just, exposes a couple of regions, come up with something that's a little bit more comprehensive. So I took a look at how VFIO works, and basically VFIO has two different IOCTLs. The first one provides some kind of high-level information, including the number of regions. And then the second call, you give it an index, and it gives you some information about that region. So effectively, you make the first call, how many regions you have, and then you loop over to the second call, and you get information about all the regions. And then what you get along, what you get about that region is an offset that you can give to mmap that tells mmap which region you want, basically, and also the size of the region. So what you need to tell mmap if you want that region. So basically, I didn't do exactly what VFIO does, but I did something similar. And the reason I made a couple changes is that I wanted to be able to have effectively hierarchical regions. So this is not so important, I think, for the control and application and NIC control bars, but more important for the RAM, because on a card you might have, on a Alveo U200, for example, you have 4 memory modules. Maybe you want to map each of those separately. Maybe you have a different bit of code that's interfacing with each one of those modules. In the application section, you're going to be putting, slightly different data in each one. So you want to be able to map it appropriately from your control software. Another possibility is with a device with HBM, like a U50 or U280. You may want to be able to map effectively each port on each HBM stack differently. And there's a number of those ports on there. So being able to pull out just that piece of the address space in a controlled way is going to be a pretty useful capability. So just an index gives you a linear list, but what I did is I added next and child indices to each link in the chain, basically each region, and that allows you to create kind of a hierarchy. So the next would point to the next item at the same hierarchy level, and then the child would point to the one hierarchy level down. So that allows you to turn this list into a tree, and everything should work. Okay, so the IOCTL implementation itself has been updated, but the backend logic right now is extremely simple. It only supports the NIC control, app control, and RAM bars. The to-do at some point is to rewrite this to handle arbitrary regions. And the idea is we'll have some structures to define the regions that will be set up and registered at some point. And then this IOCTL will just look at that when the user space software requests information about a particular region. So yeah, not a big deal, but that's how that's been looking, and that's coming together nicely. All right, and then everything else has been pretty much the same since the last time, since we finished up the let's see, the dynamic 10 gig 25 gig switching. Well, not quite finished, but yeah. Okay, so let's see, we have variable length descriptor support. I'm going to be hammering on this soon. I think I spoke about this before. I'm going to kind of implement this in 2 phases. The first one is to kind of convert the current driver and whatnot to use the new descriptor formats. And then later on, I'll take another pass over to actually fully parse the descriptors on the FPGA, which is going to be a more complex set of changes. But yeah, this is definitely high up on the to-do list. The next thing is RxQ selection logic. I'm probably going to be working on this next. So for this one, I need to put together some new control registers, store to expose all of these different parameters. And then I need to make a couple changes in terms of how things are handled on the receive path to implement this. All right, then we got the management software. I think Leon has been doing some work on getting a RISC-V core running in the application section. So this is going to be kind of doing something similar, but integrated into the Corundum core logic. I think I spoke about this a little bit before. The idea that I have right now is to more tightly integrate the core into the Corundum core logic instead of putting it at the board level, because I think this is going to be potentially useful even on, if you wanted even like a Zinc board or something like that, it might make sense to have a, soft core monitoring the PHY state and whatnot, and handling the 10 gig, 25 gig switching, things of that nature. Anyway, that's this is another thing on the to-do list that I'm going to be dealing with relatively soon. And then we have the 10 gig and 25 gig switching. This is working from user space software. I need to get that code cleaned up quite a bit because that's pretty rough. But once we have the software running, then the software will handle the kind of real-time functionality for this. And I also need to make some changes to the data path to handle things like dropped TX packets, because right now all of those are tracked with IDs, and if one of those IDs doesn't make it back, then things get stuck. And then we also need to extend this for equalizer switching as well. So we can switch between 10 gig and 25 gig, but I also want to be able to switch between DFE and LPM. So basically that gives you 4 different configurations, 10 gig and 25 gig by PFE and LPM. So not that big of a deal. We'll have to extract those for the various transceivers that appear on some of the different boards. So yeah, so I think right now I only have the register settings for the GTY transceivers on UltraScale Plus parts. So anyway, that's not that big of a deal to extract that. All right. And then I'll put up my to-do list again for a stable release here. So we got the application section, implement the register space reorg done. I mean, I guess there's a few other things that I haven't really added to this that definitely needed to be addressed. So like the IOCTL stuff, now that that's at least closer to what it needs to be, that's definitely a point towards, being able to do a, to start cutting version releases and whatnot. Let's see. So the self-contained checksum offloading, that's on my to-do list as well. Variable length descriptor support, mentioned that before. Onboard FPGA management software, also mentioned that just a couple slides ago. But yeah, the overall goal is to stabilize a hardware driver interface. So I guess the IOCTL is not really hardware driver, but driver software. But stabilizing that interface is also going to be a good idea, I think. All right, so at this point, that's about it in terms of the status updates. Now, usually I'll turn it directly over to MLE, who then monopolizes the rest of the time, which is fine. But before that, if there's anybody else that wants to ask anything or discuss anything, if not, then I'll turn it over to MLE because I think they have a few status updates. Nope, nobody has anything. All right. So
when do you think that stable release will be available? Can you guess?
Well, I mean, it's mainly in terms of, when I can get these various pieces of functionality done. I'm shooting for hopefully, end of April kind of time frame, but we'll see.
Oh, nice. End of April is, I think, pretty quick.
Yeah, I think it is too. So we'll see. I mean, definitely by this summer, but I mean, because the thing is, we also have to build some functionality on top of this, both at UCSD and then also guys at MLE as well have been asking for, something along those lines. So sooner we can get something like that, squared away, the better. But I also don't want to do it too early and then have to deal with, some of the older functionality. So the other good thing is that since we have the documentation now included in the repository, that's going to make things a little bit simpler, because as we add new capabilities and update stuff, then the documentation in the repository will match the code. Well, ideally.
Hey, Alex, real quick, would you be interested in getting additional hardware, X100s, some other boards there? Probably V9.
Well, yeah, so we discussed this before. Whatever you guys want to send me, I'll make it work, right? I'll go ahead and port Corundum to it and add it to the device list and whatnot. So,
all right.
So yeah, if you guys have an X100, that would be cool.
Yeah, I'm gonna be working on that in the next couple of weeks, getting you some, at least an X100 first. Yeah.
Yeah. Okay. Yeah. I mean, I think the main thing is that now that I've been making some of these kind of reorganizational changes to the repository, and that touches a lot of files. So now that some of those have been a little bit more squared away, then that definitely puts things in a better spot for porting Corundum to more hardware. So yeah, okay. I've also had some discussions recently with the folks at Bitware as well. So I mean, we'll see what comes out of that, but potentially some more hardware.
Good.
Yeah.
Yeah, and I just want to thank you for the other thing, the post you did for the this is the Eximic driver, but still thank you. we'll get them started on that. You may even do a temporary build, or I may do a merge and a fork and see if we can get something going there to accelerate that fix. I've actually seen that bug, I think, a couple times and was wondering about it. So thank you.
Right. Yeah. No, I actually. So yeah, and Bob was talking about a little issue I opened on the software repository for the Exonic cards, basically. This is a couple of things that I discovered basically while I was looking at the while I was building the Corundum driver, and I was looking at both the Exablaze driver and their user space tools and like Mellanox tools and a few other things at the same time to try and figure out, you know, how do you make a NIC driver? How do you do firmware updates over PCI Express? How do you do all this stuff? Because I had no idea. And I, you know, made a couple of discoveries in terms of how some of the kernel interfaces work. I learned a lot by looking at some of these other pieces of code, but in some cases, I also went and looked at the documentation. So that was one thing. I'm like, why are they jumping through all these hoops with, let's see, there's like, I think in the Exonic code, there's for example, some functions that look up based on the major and minor device numbers. And when I was doing some poking around in the documentation, it's like, well, the MIST device already does that for you. You just need to find a way to get from the MIST device structure back to the to the object that you want. And if you set things up properly, and some of the other drivers do that, then it saves you having to jump through a bunch of hoops in the code. So I figured I would go ahead and pass that along. I meant to open that up like ages ago, maybe even make a pull request or something, but I just totally forgot. So
Well, never too late. Thank you.
Yeah. Yeah, I guess the other big thing is just there's if you add a particular, or if you set a particular structure reference, then the SysFS will create some links that makes it a lot easier to get from your registered device object back to the original device, or vice versa. So makes things a little bit easier to deal with.
Mm-hmm.
So anyway, yeah, hopefully those changes will improve things a little bit. Now the flip side is I wasn't sure if maybe like some very old version of Linux did things differently, and it was done that way for compatibility reasons, you know, because I know things in Linux change periodically, especially in terms of what goes on in the kernel. But I think all of these changes have been there pretty much from the beginning. I think MIST device pretty much has always had the capability of doing the major and minor device number checking internally and whatnot, but I'm not sure about a couple of the other things. Anyway, definitely makes sense to check that on all of the different platforms that you support, make sure it doesn't break anything.
Thank you.
All right, is there anybody else with any questions or comments or anything? All right, well, let's see, I guess we got Ulrich and Joachim on here. Does Emily have any updates?
Yeah, I guess so. But first, I've got a question. To Girai, and how do I really pronounce your name correctly?
Girai? Absolutely.
Okay.
Good guess.
I guess I tried to ask this on Slack already, but that probably just didn't make it to your attention. So we once discussed about buffer pooling, and I guess Alex brought up that you did some work in this area. And we were interested in checking back with you on this. So depending on how far you went.
Some work on trying to use the page pool of the kernel. A lot of the network drivers use the page pool. And I wrote some code, but still crashing the kernel every once in a while. So maybe what I could do is I could commit my code into my repository and send you a link. Would that be good for you?
Yeah, that sounds good. So I guess Joachim may have a look at it, and maybe we try this to see whether that makes sense for us to go for it. So for now, I guess we are fine, but we think that may improve performance quite a bit, and that would be good for us.
Yeah, that was exactly what I was after as well. So okay, I'll write in Slack, I guess, once I commit my code into my repository.
Cool, great. Yeah, thanks. I guess
Uh-huh.
maybe we can also open an issue or something to track a discussion or some. I don't know if there
Yeah,
is not
sure.
one available yet.
Yeah, that's not a bad idea, because we can open that up on GitHub, and then you can just post a link to the code or something from there once you have that live.
Okay.
Right.
Sure.
Cool, great. Thanks.
No problem.
Then
I guess-
I think I turn over to Joachim first, and maybe I have another thing to add later.
Yeah, okay. So what do we have? We have our Syncmp port ready. At least we think it's ready.
All right, well, that's definitely better than I think the last time around, where it's like, yeah, this still needs a lot of work. So, yeah, okay. Let's definitely get the ball rolling on that.
Yeah, I just did another rebase today since there were some changes. And
Okay.
I'm about to check them out if it still works. But looks, yeah, good so far. So yeah, the point is, yeah, somebody has to look into it and then decide what needs to be changed, or if nothing needs to be changed, and the question is, yeah, take it in.
All right. I mean, my guess is that it's going to be pretty straightforward, that not much is going to have to be tweaked, but, you know, we'll see.
Yeah,
Once you have something that's looking more reasonable, then I'll take a look at it. So
the main thing is, yeah, more or less about the board specific code, or the fact that for this port now, there's essentially no board specific code used. I kind of put in a fork in the common probe. And use especially a platform open firmware specific routine to fetch the necessary parameters, meaning the MAC addresses, and for handling I2C accesses.
right, yeah.
So that's a total separate thing from the existing board specific code. It
Right,
currently
yeah.
lives in the main file, and I'm a little bit, yeah, unsure about
I was thinking maybe
how
that
you
should be
like
moved
it
somewhere else. Yeah. Well, I mean, I guess we'll have to see what makes the most sense. I mean, I don't really have a strong opinion on how things should be organized. It's just, whatever makes the most sense. So if that seems like something that should be, scooted off into another file, then that makes sense. Like I pulled the interrupt stuff off into another file because I'm like, this is logical. So if some of that stuff, it makes sense to peel it off into another file, then, that might make sense.
But the main point, I guess, here is, what about if when there's the RISC-V processor, which is then for all the PCIe based devices, is managing I2C and all this, how we want to do it for the Syncmp then? I mean, for the Syncmp case, it's kind of natural to really do that from the Syncmp.
Right, yeah.
Which would
for
then
all the
be
I2C stuff, yeah, that definitely makes sense. So the thing with the RISC-V CPU is I'm actually thinking about making it at least an option on whatever you're running on, not only specific to PCI Express. because you might want to have that core say handle the line rate switching or something, right? So that can all be the same kind of code base across all the boards to handle, you know, reconfiguring the transceivers and whatnot. So in that case, you would still have that, you know, mailbox interface effectively to talk to the core, and then some things would go through that. Then the question is, okay, for reading the MAC address, you know, then it becomes, you know, whether you read it from the whatever the platform device subsystem is versus reading it from the RISC-V, that then becomes, I guess, platform device versus. Yeah, I guess we'd have to think about how do you make that decision exactly, because the RISC-V can't exactly poke at the platform device stuff. So I guess the driver would just have to know. I guess for platform devices, you would want to read it from somewhere else. For stuff that isn't a platform device, then you'd go through the RISC-V.
So yeah,
that might require some thought. Yeah, I'll take a look at the code that you have right now and try to get my head wrapped around it. So
that to just describe in a short way. Currently, we have kind of invented a few device tree properties for the device tree node, which is representing the MQNIC. And these properties basically specify where to look for the MAC address in terms of EEPROM and offset. And another properties to basically find the I2C EEPROM nodes to use for SFP EEPROM access.
Right.
So that's coming from device tree, and the device tree is kind of the hardware description. So it seems like a good fit.
Yeah, definitely. Yeah, for the device tree, all that stuff definitely makes sense. There was one thing that's kind of annoying about the I2C subsystem. Maybe this is less of a problem with how things are wired up. We'll see. Basically, the problem is that the optical modules are not always, you know, installed, right? So if you boot the system up with the optical modules unplugged, then you plug it in, it won't create the EEPROM entries in the, you know, in the SysFS. So I'm not sure if there's a way to
in the PCIe case.
I think it doesn't matter.
Nah,
because when you load, so the problem is that the EEPROM driver tries to read the EEPROM, and if there's no device there, then it's like, oops, sorry, I can't continue probing because there's nothing here. So there's no module plugged in, then it's not going to create the EEPROM entries. So
I'm not sure about the platform device case here. I think that I mean it's rather static. There's no auto detection going on in the device tree world. So
no, the auto detection is not in the device tree. The auto detection is in the EEPROM driver itself. When something tries to load it, when you call probe on it, it tries to talk to the EEPROM. So it doesn't matter if you're calling that manually from the PCI Express probe code, or if the device tree is calling it. I mean, I'm assuming it uses probe to try to connect it. So if that's what it does, then you're not going to get the device tree or the entry being created. I mean, it basically still creates the device. It just doesn't attach the EEPROM driver to it. Something like that. So there's still something there at that address. It's still, Linux is still aware that there is some sort of device there, but it doesn't attach the EEPROM driver to it. So there's no like EEPROM file that you can read and write to.
Yeah, okay.
And this is just a limitation of
to check that out.
The EEPROM device, which is, so I don't know if there's like a different way you're supposed to talk to things like QSFP devices. I was just using the SM bus read and write things because that doesn't seem to be dependent on there actually being a driver connected to that I2C device. So it's possible if we're just using the SM bus read and write from the driver, then, you know, it might work regardless. But That might require
Yeah.
some experimentation. And in principle, I don't think it's that big of a deal, right? You boot the Zync up with no SFP plugged in, and then you plug it in and you see if it works.
Yeah.
Yeah, and otherwise, I guess we may have a look at other boards providing SFPs and how they handle this. So maybe as there is a plug event that could be generated, maybe they use this to trigger the creation of this node.
Well, I think
I don't
most
know.
devices just don't even use I2C subsystem.
Possibly, yes.
Because
That's
I
also
know, speaking of the Exonic device, that they re-implemented their whole bitbang I2C stack in the driver. And originally I'm like, geez, this is way too much effort to jump through all these hoops and make that happen, because the Linux kernel has their own I2C bitbang subsystem. But then I've been bitten several times by that changing and me having to add a bunch of if-defs. So maybe avoiding that is the more prudent solution. That's one of the reasons I'm like, let's get this into a soft core. So I don't need to continue maintaining this code.
yeah.
Okay. Well, I think that's once we get that the kinks hammered out of the Zync stuff, getting that merged in is going to be pretty good. I guess we could potentially merge that in a few pieces as well, instead of merging the whole thing at once. Just so you don't have to keep rebasing everything all the time.
Yeah. Yeah, I guess maybe when we add at least some platform dependent code that doesn't harm anything being done on the PCI Express side, right? So I guess that should be possible to merge this in early.
Or even some of the other stuff. Like I think you have a whole makefile infrastructure for building Zync stuff. I could certainly pull that in, because that doesn't conflict with anything.
Yeah. Correct. Yeah. Okay. Makes sense.
What about the DPDK driver that you guys have been working on? Is there any news on that front?
Right. So what we
there were
did
some
internally
signs of
now is some formal round, let's say, as this gets now publicly available. We needed to put somebody in the loop that has to say, okay, that's how the license will look like and whatnot.
Okay.
We did this. So we'll push it. I don't know. I think I won't get to it today, but then I'll do it tomorrow. So then it will be available. This is still the first version. It only supports a single interface.
Right.
And it's based on an old version of Corundum. So it's the pre-registered
we have to go back a
block
few...
change.
Oh,
right.
Okay. So it won't load
but I
the
guess
current version of the tool with the current version of the FPGA. So all right.
Exactly. So we included in the this will be a single commit basically, and we included a reference hash and link to the Corundum repository that is the base for this build basically.
Gotcha. Okay.
And so I guess that should be easy to match this, even though it's not up to date. We will do this like in the upcoming, I don't know, couple of weeks, I guess. So this is a little bit put on pause now for 3 weeks, I think, and then we'll revisit this. But I think it's enough now to get an initial discussion kicked off.
Right. Okay.
And there will be some rework going on anyway because of the register API changes. And yeah, whoever has more input and comments and help and whatever. So we're happy to go through this and then incorporate changes during the rework anyway. Yeah. So I guess it's a good point to kick off discussion.
Oh,
All right.
That's nice, Ulrich. Thank you.
Yeah, we're happy to.
Yeah, I definitely think there's going to be a lot of people interested in that. So that could potentially help get some, bugs worked out and performance improvements made if, some of the people that are interested in using it are also going to be willing to help put some time into improving the performance and whatnot. So
I'm sure
Right, I
about
guess
that. And I
kicking
guess
out
there will
the
be a lot
initial
of
version is the big thing you need to jump over. Pardon,
Right.
go ahead.
I think there will be a lot of people to help improve every year and in the future. I mean, maybe after 4 years, there will be many people who are willing to help to improve even better. I'm sure about that.
After 4 years, that's a long time to wait, but
Maybe I am telling about the time that it will be guaranteed to be so, but I'm sure that it will happen earlier. I mean, after 4 years, maybe it will be very stable and it will handle a lot higher throughput. Maybe who knows what will happen.
I certainly hope so. Anyway, all right. Well, that'll be good once we get that that operational. I think being able to do like even bandwidth testing and whatnot with DPDK instead of using iPerf is going to be a step up. So anyway,
Yeah, I
I
guess
think-
then we would also need to agree on a test method or something. I guess that makes sense.
right, yeah. That's something I was putting a little bit of kind of high level thought into. It might be nice to have, like, for example, a set of tests that can be run on any kind of new board design, basically just as a sanity check sort of thing that tests all of the major stuff, right? You run iPerf, you run DPDK, you run ETH tool and whatnot, you poke at a bunch of stuff, make sure you get all the expected results. Yeah, and being able to do that in an automated way would be useful.
Looks like there are a lot of guys who are interested in DPDK. So once we get it up and running, I think there will be a lot of interest on Corundum.
Yeah, so I've had a number of people ask about DPDK support, but it's always a question of, are people interested in just using it, or would they actually be interested in helping to build it?
I
But
think
yeah, there's
users
definitely a
will
difference
help it
between
to
let's
build
get
it.
the first version running and improve that versus let's let's go from no driver to having something. Yeah, once you have something working, it's a lot easier to improve it than going from
And
nothing
yes,
to having
yes.
something. Yeah.
Yes, and software guys will be interested in it too. So as you know, there are many of them, and I'm sure they are going to help.
Yeah, definitely.
At the same time, we already learned that perhaps the next step is then to not just have DPDK support, but to have both, to really have kernel support plus DPDK at the same time using the same device. So that's
Right.
another story.
Yes, that's to be honest, one of the reasons I've been holding off on writing a DPDK driver, because if you want to do both at the same time, now you have to coordinate somehow between the two. So what sort of interface would you use, and how would you make that work? But yeah, ultimately that's going to be the most flexible solution, because then all of your standard kernel tools work, right? ETH tool works, and you can expose all of the device files and whatnot, and the application can, you could use a separate program to talk to the application section and yada yada yada. So yeah, it ends up being, I think, a lot more flexible. But yeah, there's definitely a question of how you're going to make that connection. So I was actually looking at how, like, the Mellanox driver does that a while ago, and they seem to be effectively using a bunch of their RDMA API calls for that. I guess like the packet sending and receiving and whatnot is handled by some RDMA APIs effectively, and they're using those from DPDK basically. So it didn't seem like, yeah, we can do the same thing here easily. It seemed like that there might be some additional complexity involved. So that's definitely something to think about. I'm not sure how the pieces are going to fit together. I guess the other aspect that's potentially worth looking at is I know DPDK can talk to the AF XDP subsystem,
Yeah.
right? The XDP
Yeah.
sockets. So if we can get Corundum to support XDP, and I know there's the folks at Axbrid got that working, but they have a lot of additional stuff that sits on top of Corundum. So peeling that off would be useful, just to get the XDP support. And then I don't think you even need to do anything special for DPDK. I think it'll basically just work because it's DPDK knows how to interface with XDP.
Yeah, yeah. I mean, that was, I think, the whole intention of XDP to, yeah, get
Basically
rid of
the
these
Linux
from the
version of
kernel
DPDK,
perspective to
basically,
get
yeah.
rid of these ugly user space solutions which do kernel functionality again in user space, which is kind of nonsense to them, I guess.
I mean, it makes sense to support both, right? Because in certain circumstances, I can definitely see that DPDK is the way to go. In other ways, in other circumstances, the XDP definitely makes more sense. So the nice thing about DPDK is you can just pass the whole device through to a VM or something like that. But yeah, slightly different story with XDP. And then you get into stuff like SRIOV and whatnot that so support multiple VMs and such. So that's another thing, another bridge that should probably be crossed at some point is SRIOV. But you know, one step at a time. All right. Any other questions, comments, announcements? Ulrich, you wanted to say something? Okay.
As you just said, one step at a time. We just noticed that in the driver, your recent changes, peeling out the scheduler from the port into the interfaces, they're not really reflected there, right? Is this upcoming, or is it just the driver will stay as it is?
There's probably things that need to be updated. Yeah, so I guess with that one, yeah, I think there's still some more kind of hierarchy adjustments that need to be made. Right, so I think part of the trick with the driver is that it's been unclear kind of how to expose some of this functionality. So yeah, it's not like there's a nice little kernel interface for controlling a scheduler or something like that. This is definitely much more internal to the driver. So there might be some discussions to be had in terms of, you know, how do we want to expose, you know, all the knobs to change how the schedulers operate and whatnot. Because right now it's kind of rudimentary. I'm not sure if you have any thoughts on that component of it, but yeah, I think I got the hardware updated, but need to make some adjustments to the driver to finish that off. I'll add that to my to-do list to take another pass over.
Yeah, so I guess it does work like it is. It's just, as you said, the structure is not represented the same way as it is built in the RTL. I guess for most situations that there is no need to put this in place, but especially if you have multiple schedulers attached, and then it kind of, yeah.
Well, so I guess the other aspect of it is that I'm still not completely done with the reworking on the hardware side. So there's a couple of other changes that that need to be made, and one of them is adding the register blocks on the receive side for handling the RSS stuff in the queue selection. And that one, those are going to be tied more to the interface and not so much the ports. That's not really a big deal, but going in the other direction, I need to add some register blocks for let's see, basically mapping the TCs onto like the PFC levels. And that's going to be like on a per port basis. So I got rid of the port module a while ago, but I think I may need to bring back some of that to implement, a few odds and ends. And that kind of screws with the hierarchy of some of the interconnections a little bit.
Just to mention it quickly,
Yeah.
there's the entry point for this observation for us was the confusion that the scheduler representation in the driver is still placed inside the port structure.
Right. Yeah. Yeah.
And
so I think what I need to do in the driver is kind of convert that port structure. I think I basically just need to rename that a little bit. Well, all right. I need to take another look at that. Yeah, I didn't fully peel things apart. I think part of that. Oh, the other thing I need to do. Yeah, actually, I've not completely done that in the code, because what I need to do is add another parameter at the top level that's like schedulers per interface, basically, and then I'm going to set that to ports per interface. But then you can override it, and then that needs to be propagated all the way down properly, and I need to make sure that's registering all the schedulers correctly. And then, yeah, once I have that, then those numbers can actually be different. So you'd have to register that in a different structure in the driver. Yeah, like I said, I need to take another pass over this. I think both on the hardware side and on the software side. So it's a lot closer, but there's still a few things that I need to do. So yeah, and if you guys have any suggestions for how stuff needs to be brought out, then I'll take a look at that.
Yeah, I guess for us currently it's not really a problem, because we are at least aiming currently for a very simple solution, multiple interfaces with a single port and a single scheduler. So simplest case, I would say.
Right. Okay. Yeah, I'll take a look at that this week maybe and get that squared away, because I also need to do need to add those RSS related registers. So that's all kind of touching some of the same stuff. All right. Okay. Anybody else have any questions, comments, anything? No?
Actually, yes.
Oh, you have another. All right.
Yeah,
fire away.
Just wanted to give somebody else a chance at least. We came across the following question. For our scheduling, we basically need to know the data paths clock, the frequency for calculations. And we thought about, well, yeah, let's just have a register in our block, in our scheduler block, and expose that so that our software can read that and do its calculation based on that. But then we thought, well, that might be something which should go into a kind of a MQNIC global information structure, which is, for example, telling the data path frequency. Another question is where to put it in the main info block with all the IDs. I guess that's not really the place. It's a sum of IDs, a collection of IDs. Perhaps another block which is
some of the kind of
info block. I don't know.
Yeah, I was thinking there is a nominal period register for the PTP clock, but the PTP clock doesn't necessarily have to run in the PCI Express clock domain. In fact, that's another thing that I've had in the back of my head is some of the time synchronization stuff, that it might make sense to rework the PTP clock so that that can run in a different clock domain, like in the transceiver transmit clock domain or something like that, which one might be more stable than a PCI Express clock. And then two, if you're doing something like Syncmp and you're going to be slewing the transmit clock, then you'll do your time synchronization by slewing the transmit clock instead of adjusting the period registers in the PTP clock. But yeah, in that case, then that register wouldn't represent what the data path is doing in terms of that frequency. So yeah, well, what other hardware related information should be exposed that isn't already exposed?
Yeah, good question. We also thought about that, but up until now, only have the frequency. So
yeah,
basically,
I mean, I guess the other concern is like you could potentially expose like the clock frequencies for the max effectively, but those will change, right? For the 10 gig and 25 gig stuff, those will change at runtime. So, and then you'd have to have one for each Mac, and yeah.
we also need this.
Discussion. Oh, Gray?
Yeah, one thing I used was forward error correction, RSFEC, and that's not exposed to the driver.
Oh, right. Yeah. So this is definitely on the list of things that I wanted to expose at some point is control registers for PHY and Mac layer stuff. And I haven't totally gotten my head wrapped around exactly what needs to be exposed and how, but I do now have a DRP bridge effectively that is intended for, at least originally, for talking to the transceivers, but that could also be used for talking to the 100 gig max. And that I can also extend the DRP register space in a similar way to control some of the other, Mac settings, including enabling or disabling the RSFEC. Yeah, for the most part, everything that I've been talking to with Corundum requires RSFEC to be enabled. So I'm just like, I'm going to turn that on, and then that'll be it. It's like on the Mellanox NICs, I don't even think you can turn it off. It's just it's on, and that's it. But I think on some packet switches, maybe it's off and you can't turn it on, like they don't support it for whatever reason. So I don't know.
I think it has to do with the type of fiber you're actually using. I think if you use long range fiber, the RSFEC is disabled by default. And then if it's SR,
that's possible. But my read of the specification is that RSFEC must always be supported 100 gig. Whether you turn it on is a slightly different story.
Okay.
Yeah, so which does make running on things like ultrascale devices annoying because they don't have hard RSFEC. That's a soft IP on ultrascale. On ultrascale plus, it's actually in hard logic, which makes things a lot more convenient. You do need to generate the license, but yeah, not that big of a deal beyond that. Okay, so yeah, that one is on my to-do list, hoping to get that operational, well, at some point. All right. Let's see, Joachim, was there anything else to mention there, or?
No, not really. So just to mention it, we kind of need the data path frequency,
right.
The number of queues, which is there, is already there as a register. And then we also need I guess the MAC frequency, which tells about the actual data rate, which is possible, since we are going to have two different speeds here, 10 gigabit and 1 gigabit.
Yeah. So so I think these okay. So I think the Mac level stuff maybe should be handled, in some sense out of band, right? Because the Macs are not really part of the Corundum core logic, right? That frequency is going to be more board specific or whatever, or dynamically changing. So potentially what we could do is have have a capability for the softcore to report that. So if the softcore is present, then you can say, hey, softcore, what's the frequency of this Mac, or what's the rate of this Mac? And then the softcore would know how to do the board dependent thing to check that. And then that'll give you that information. So that might make sense there. In terms of the the data path frequency, maybe what we can do is add it to the interface level control block, basically, and we can have a register there that exposes the interface data path clock frequency.
Mm-hmm.
And then, yeah, it'd be duplicated on both interfaces if you have more than one, but that could be a place to put it instead of all the way up at the top level. And you could say, yeah, this applies to all of the data path components on this interface.
Mm-hmm. Okay, yeah.
Just to make sure, I guess for the max, we don't really need the clock rate, but the nominal speed, I guess.
Yeah, the data rate.
Resulting data rate, yes. And I guess the right thing would be ETH tool here, the standard ETH tool information, which otherwise tells about the, I don't know how it's called, the advertised and the negotiated speed.
Right. Yeah. Well, that has to get that information from somewhere. So
yeah, right. But that's the interface, I would say, to user
right.
space.
To user space. Yeah, that's true. Right. So I mean that's kind of the idea with a lot of this stuff is that ETH tool will connect that to whatever the hardware interfaces are, so it can get all the necessary information. So, you know, I know. Oh, I guess one of the things I didn't mention is that I went and rewrote a lot of the ETH tool implementation for the module EEPROM access because that changed recently in the, well, I guess not all that recently. A few versions ago, that was overhauled. They added a new API, and that's used when you're talking to certain optical modules to read some. They have multiple pages that you can select between. So when the higher level pages are present, then it tries to read those. If those pages aren't present, then it doesn't even. ETH tool complains bitterly. It doesn't even report information from the first pages that it was able to read. Anyway, so I went ahead and implemented that, and it seems to be working. But yeah, the idea will be so right now all that's done through the Linux kernel I2C subsystem. Once we have the software running, then those accesses would be routed through there. So
okay.
All right. Well, we're pretty much at time here. If anyone has any other questions or comments, happy to take them. Otherwise, if people need to clear out of here, then we can end the meeting. All right. Going once, going twice. I guess I will see you guys in 2 weeks then. Thanks to everybody for tuning in.
See you next week and
Yeah.
next week.
All right. See ya.
Okay, see you.
Thanks, everybody. Have a good time.
Have a good week.
Bye.